Good morning, LinkedIn, Live, YouTube, Periscope, Twitch, Facebook. Hope you're having a great morning. So today I am going to do a quick record of one of my podcasts, not podcasts. That sounds like where you would store brandy or some kind of thing while it ages. Anyway, you could tell I definitely could use an extra cup of coffee. My name is Frank Lavinia. I am the host of co-host of DataDriven.tv, co-host of Impact Quantum, and my blog, which just turned 25, is franksworld.com. Today, I'm going to be recording an episode of Impact Quantum, podcast about quantum computing, specifically made for software engineers, developers, that sort of thing. Hey, good morning, Tom. How's it going? Yes, I'm going to get coffee right after this. I also have my production assistant over there doing his schoolwork. So I promised him I would make this quick so his school day wouldn't be too interrupted. So, all right. So first, because this is Impact Quantum, we need that 10 seconds of dubstep. So I'll be right back. Thanks for that intro, and I am here to talk about, can quantum computing prevent another AI winter? So I just want to give a shout out. Good morning, Shiv. How's it going? Hope you're hey. Today I'm talking about quantum computing preventing another AI winter. So if you're just tuning into the show for the first time, I'm recording this live on multiple streaming platforms, and just want to kind of talk about the winter that may be coming for AI. So if you're not familiar with the Game of Thrones, basically the idea is that, they have this saying where, winter is coming, right? And they all say it very dramatically, right? Let me start this over. All right, so this is Impact Quantum, and I'm going to talk today about, can quantum computing prevent another AI winter? Winter is coming, an AI winter, that is. If you're not familiar with the term AI winter, it refers to a period in time when innovation in the AI field stalls. Now, this is due in large part to lack of computing power. And now this lack of computing power leads to a lack of innovation, which then ultimately dries up the funding, the VC funding, which in turn freezes work in the field. So when it comes to AI and computation, or computation in general, we think we're immune to limitations of hardware. And we've been fairly blessed over the last several decades because of Moore's Law, or the idea that you could fit more transistors on a chip and you can get more computing power, and it doubles every, depending on who you talk to, 12 to 18 months. And in your hands, literally in your hands with your cell phone, you have millions of times more compute power than NASA had at their disposal during the Apollo 11 program. If your site is under heavy load, just shell out some more cash and you can scale. You can scale up or you can scale out, right? Scale horizontally, scale vertically, however you want to scale. You can do both. So access to computing power these days is generally not an issue. I could spin up a very powerful VM in the cloud, anybody's cloud. I would use Azure, of course. But at the cutting edge of research and development in AI, we might be reaching a limit of what's feasible, certainly economically, or possibly even possible. Ooh, that sounds funny. Possibly even possible. Recently, MIT researchers sounded an alarm that deep learning is reaching the limits of our current computational systems. Does it sound alarmist? Right? Clickbait? Does it sound far-fetched? Well, not so fast. You probably have heard now of GPT-3, and it is a text generation model. It's a transformer, and that has 175 billion parameters. Now, depending on what source you read, to train this model with that many parameters on a corpus of documents and text. And if you've not played around with GPT-3, it is uncanny how good this thing is. I mean, seriously, it's science fiction level of text generation. Perhaps on my other show, Data Driven, we'll do a kind of a deep dive into it. Now, depending on who you believe, this cost about $4 to $12 million to train this thing. Depending on how you're going to use it, how you're going to monetize it, I'm not sure who's going to get that investment back or how. I think that's an interesting creative problem. But anyway, you slice it, $4 million, still a lot of money. $12 million, 3 times that amount. So it's still a lot of money. But it really was money well spent. I mean, GPT-3 is a milestone achievement in the field of NLP, right? Natural language processing. Now, what's interesting is in terms of scaling, GPT-2 was really good at this, right? And GPT-2 was the predecessor, and it had 1.5 billion parameters. And honestly, there's a good chance it would have passed the Turing test because it was really well. So you go from 1.5 billion parameters to 175 billion parameters. So you can imagine how many parameters would GPT-4 have, right? How much would that cost to train, right? Well, I only have one data point right now. But the fact is that this cost and the amount of compute at these edges are going up. So the Turing test, if you've not heard, is kind of developed in the 50s by Alan Turing. Movies were made about him. He's a founder of computer science. Let's say something again. Let me start that over. So if you've not heard the Turing test, it was developed in 1950 by Alan Turing, the founder of computer science as we know it today. And it was basically meant to... All right. So while I have to edit out bloopers because somebody's not using his headphones. That's okay. That's okay. I'm not mad. Thomas Duclos, I'll take comments soon as I'll edit these out of the live show, depending on this. Bernard Marr just posted this in the back of the 5th of November. I will have to check that out. Totally check that out. They don't work. Okie doke. GPT-3. Yeah, I definitely want to check that out. Interestingly, there's an app on the homeschooling, right? Recording a podcast in the time of a pandemic. It's fun. Hold on one second, folks, while I deal with a bit of a glitch in the matrix, if you will. All right, everyone, just bear with me while I deal with a quick technology problem with my kid's computer. In the meantime... I have to get something for PE class. Okay. All right, so this was the first time I've actually tried to do this while he's in my home office here, on the bridge here of the Nebuchadnezzar. All right, so back to the subject at hand. The Turing test was developed in the 50s by Alan Turing, the founder of modern computer science, and ultimately it was designed to test a machine's ability to demonstrate intelligence equivalent to or indistinguishable from human intelligence. And basically, the test was a human would judge whether or not a natural language conversation over a chat kind of mechanism would be human enough, and that a computer would be unable to talk. Woo, it's blooper day. All right. So basically, the idea is that the computer would have a conversation with a human, and if the human can't tell if it was talking to a computer or another human, then that AI would pass the Turing test. Now, what's I think surprising for a lot of folks is that AI has been around for decades. Alan Turing did a lot of his innovative work in the 50s. That means we're in the 7th decade of AI research. So since Alan Turing, there have been advances, and more important to this conversation, stalls in AI research. DARPA cut a lot of funding to research problems, DARPA being the Defense Advanced Research Projects Agency, I believe, and they are known for creating the internet, for really kickstarting the self-driving car revolution in the early 2000s. And ultimately, DARPA cut a lot of the funding because there wasn't really that level of progress. If you think back to the 50s and the 60s, people thought, you look at the sci-fi at the time, people thought that AI would be commonplace in the not too distant future. Keep in mind, this is 40, 50 years ago. We're still not quite there, although we're closer than we would think. So in the 80s, we saw the rise of expert systems and early work into neural networks. In fact, a lot of people are surprised that neural networks research into that really boomed in the early 80s. However, the costs of these systems were becoming prohibitive or impossible due to processing power constraints at the time. Does that sound familiar? So the longest AI winter so far has been basically from the late 1980s until the early 2010s. Although maybe you could debate with me whether or not the early days, the early days of big data in the late 2000s would count as part of the end of AI winter. It certainly was the AI spring, if you will, or the start of it. But while actual AI innovation and advances had stalled, there okay, cool. So you can't hear that. I don't think this is in the feed. While actual AI research and innovation stalled, science fiction AI blossomed. Terminator, Star Trek, with the computer-activated voice, and Commander Data, who was an android. And of course, the ones that really kicked us off in the 70s were R2-D2 and C-3PO. So my first brush with AI came during kind of towards the end of the AI winter, or maybe right smack in the middle of the end. No, wait. That's not true. Whew. I'm processing multiple feeds in my head right now because the headphone situation. Anyway, my first brush with AI came during kind of like smack in the middle of the AI winter in the mid-90s when I was a computer science student. And there was actually a course offering called AI. And the professor was a noted researcher from IBM and was, decorated in doing a lot of this. And his big shtick was Prolog. He would always praise Prolog to the sky. And I never understood, to this day I still don't understand it, why he was so hot on Prolog. But I mean, it was the early 90s, right? This was really when the internet was just and the web was certainly in its infancy. Um, so to hear him talk about Prolog, I mean, it was the programming language and paradigm for the future, and it was coming. It was just inevitable, right? It was just around the corner. I've heard a lot of things in my career that are just around the corner. Sometimes I've been right, sometimes I've been wrong, but wrong in the right way. So after working through the class projects, I was kept waiting for this big reveal of like what made Prolog innately intelligent. Never came. And the final project was really more about recursion than any kind of with the sprinkle of logical inference. It was not Skynet, right? I felt like I'd been lied to in the course description. So I finished the class deflated and really just thought that AI was either science fiction or just a bunch of if-then statements, ultimately in recursion kind of all of doing that, all bundled in. So this really left a bad taste in my mouth, and I was very skeptical of AI, right? Hard to imagine, right? Me being skeptical of AI. I even saw an early demo of what ultimately Microsoft released as the Computer Vision API cognitive service at a DC Tech Fair, about 5-6 years ago. I was a little impressed, but the guy showed, and I actually have a YouTube video that I recorded, and I'll put that in the show notes. He showed this thing, and he showed a picture of a cat in a window, and the AI came back with a description saying, this is a cat in a window. And I was impressed for about a quarter second. And then I realized, there's probably some kind of underwhelming explanation under this, right? Fool me once, fool me twice, right? Couldn't have been more wrong. Pardoning the expression, there's been a quantum leap forward here. Blooper time. This is the first time I'm reading off a script, too, because it's not really a script. It's actually an article I wrote, because I think that this message needs to get out there again and to a wider audience. All right. So since then, and my experience, I do a much better job keeping an open mind, because obviously if I had caught on to the AI wave 5-6 years ago, I think that would have been better for me personally to develop myself, as well as get the message out there for other folks, and stuff I've been doing with the blog and the podcast, stuff like that. So I kind of implemented, if you're familiar with World War Z, right? They have the 10th man rule, right? So if I initially react to something with extreme skepticism, part of me is kind of like, I really should take another look at this with a slightly more open mind, right? That has helped me kind of uncover things, including this, right? So when I started hearing whispers of slowing innovation in AI research. My first inclination was to dismiss it right away. However, because of that experience, I'm like, you know what? Maybe I should take a closer look at this. And this was November. And this is ultimately the genesis of what you're listening to now, is the Impact Quantum podcast. And the idea was I happened to be at an internal conference that Microsoft Research throws every year, twice a year. This is back when we could travel on planes and not have to wear masks. This was the before time for sure. And this conference, there was the second day keynote was about hardware. And again, I thought I was going to learn some big shebang thing about AI, but it actually was about hardware. And here's the thing. It was actually interesting. In fact, I even recorded a data point, which is a short episode of Data Driven with my explanation, because the presentation opened my mind to this new model of computing, one that could really change the world by solving problems that with current compute are intractable. So ultimately, it was an aha moment for me in terms of what quantum computing can do. And ultimately, we are adding more and more compute challenges to our existing infrastructure. At some point, our existing infrastructure is not going to be able to keep up in the ways that it has over the past 30, 40 years, because our circuitry is getting so small that we're starting to run into the problem of quantum physics. And I like the idea of leveraging that power, not having that be a barrier, but having that be a changed paradigm. The limitation, the problem is the solution, if you will. And I like this idea of using the rules of quantum physics to our advantage. And that's ultimately what a quantum computer does. So the key here is that quantum computing is not going to be a luxury thing or that that gee whiz thing in the future. It's very much needed soon. We really need some of the things we would get out of quantum computing now. But really the key here, this is the important thing, is we can't assume that the last 5 years of innovation in AI are going to continue into the next 5 years. In fact, that may actually slow down because we can't keep up with the demands researchers are putting on. Does this sound familiar? This is exactly what happened in the 80s. This is exactly what happened in the late 60s. Right? It's happening again and again. And there's one thing as a data scientist I can do, spot patterns. And this is a pattern. But here's the thing. We have a way out this time, right? And hopefully we've all learned from the past that limitations of compute power, both in terms of what's actually possible or commercially viable, precede an AI winter every single time, right? Because ultimately what causes an AI winter is the dry up in funding, right? So whether or not something's possible is one thing, but whether or not it's economically feasible is another. So quantum computing is really kind of the way out, right? It could prevent another AI winter. We're not there yet in terms of practical use, although from what I've been reading, we're a lot closer than even I thought we were. So quantum computing is a huge opportunity right now for you, for me, for anyone who wants to get into this space because it's about to explode, right? 5 years from now, recruiters are going to want somebody with 5 to 10 years of quantum computing experience, right? There's not a lot of people in the world like this right now. And it's again, right now, if you want to get into quantum computing, we're kind of at that inflection point where to work on quantum systems, you kind of have to have a degree in quantum computing, right? Up till now. But did you know that at one point you had to have practically a degree in electrical engineering to program a computer? But as time evolved, tools got better. And the barrier to entry was much, much lower. And I see the same thing happening here. You're already seeing quantum development kits or SDKs for quantum computers, right? Whether that's Q#, whether that's Circ, whether that's there's another one, PyQ or something like that. It's basically a quantum extensions for Python. You don't have to have a degree in this type of technology. And now's the time to start experimenting with it. Quantum is coming. It's going to require new skills. It's going to create new opportunities that we can't even imagine right now. And to that point, I'd say now's the time to skill up. So hopefully you'll stick with me here at Impact Quantum. Go to impactquantum.com, subscribe to us on iTunes, et cetera, et cetera. Definitely check that out. I probably will post this to the Impact Quantum podcast later. But if you want a more, this is a retelling, if you will, of a story I wrote on LinkedIn. So definitely go check that out. At this point in time, I want to say thank you for listening, and I will answer the questions that come in live. So Thomas, Great Lake, if I've not already seen it. History of AI. That would be definitely cool to do. That would be cool to do like a kind of a documentary type thing on AI. I certainly have the video kind of resources and stuff. It's actually a good idea. Although Thomas, that's looks a little sketchy there. It's an IP address. You're not gonna. Where am I going with that? I definitely will have to check that out for sure. So I just want to thank you, everyone. So yeah, I definitely want to take a look at this in terms of what this is doing. I've been heads down on some work projects, so I haven't really been doing a lot of quantum stuff. You'll see the post in the show have slowed down a bit, but data driven is going strong. Eddie and I are working on season 4. I'm gonna start I have a podcast number 3 is kind of in development, and I'm also pondering doing kind of a um, mini series on my 25 years on the web with Frank's World. And okay, he's doing PE. Okay, my kid is doing PE, but doing push-ups on the floor. PE over Zoom is just weird. 2020 has just been bizarre. That's all I'll say. So Thomas assures me I'm safe. Well, I definitely will check it out. And let me know in the comments if you think like an AI documentary thing would be kind of cool. That'd be fun to make. I love doing video production. I don't do it nearly enough as I really should. So with that, I will bid you all adieu. I have to prep. I'm going to be a guest on another podcast today. More details on that shortly. And got a bunch of other stuff happening today. So if you're not familiar with it, be sure to check out. Hey, where's my captions? My cool stuff. You can follow me on Twitter at Tableteer, and you can see what I'm up to. franksworld.com, datadriven.tv, and impactquantum.com. And for now, I will let the nice AI lady finish the show. So what we actually do now, we actually have a AI doing the voiceovers, the intros, and stuff like that. So we've actually come up with a name for her. Oh, cool! I'm important enough to have spammers. Nice. Look at that. I'm important enough to have spammers on Twitch now. Nice. See, most people look at spammers and stuff like that, and they see that and they get mad. And I'm like, I'm important enough to spam now. If you're not important enough to spam, then I love this. They've actually pasted it. I'm probably streaming on 2 channels, so to make it look legit, they have different usernames. That's awesome. Oh, and it's a .ru address too. Speaking of safe, yeah, a buddy of mine, he started a blog, and he was mad because he kept getting a lot of comment spam, and I'm like, dude, that's important because like you're now considered worthy of spamming. So anyway, with that, I will answer any questions in the comments. I always try to do that, and you have a great day.